Hi there. Welcome back to another episode of Algebra in Words. To pick up on the last video in which we went over some of the basics, including defining what are like terms, I'm going to go over a few problems that deal with like terms and combining like terms. We're going to go from simple problems and get progressively more difficult. I'll probably go over about 6 problems or so in this video. So anyway, let's get right to it. I have a few problems on the board. Let's look at the one at the top. The problem is negative 14x squared minus 10x squared. Okay, so what we want to look for is, are these like terms? And just a quick refresher, what are like terms? They have to have the same base and the same exponent. If they don't have both of those, they're not like terms and they cannot be combined. Also, a quick reminder, the coefficients, the numbers in front of the variables, really have nothing to do with it except for the fact that when we combine by the coefficients. But other than that, they have no bearing on whether the terms are alike or not. Okay, so let's focus on the variables. Are these alike? The answer is yes. Why? Because they're both the same base, x, and the same variable, 2, x squared. So in that case, they're alike. We can combine them, and we're just going to combine them by the coefficients. Think of negative 14 minus 10 is equal to negative 24, and attach the like term x squared. The answer to that is negative 24x squared. Let's look at the next one. In the next one we have 5a cubed minus 7a squared plus a cubed. Alright, what are the like terms? Well, clearly all the variables have the same base of a. But do they all have the same exponent? And the answer is no. This term has a cubed, this term has a cubed. These two are alike, but this one is not alike because it does not have the same exponent as the others. So we're going to combine the a cubed terms, 5 plus the unwritten coefficient 1 of a cubed is going to equal 6a cubed. And since there's no other like term with the negative 7a squared, we're just going to rewrite it. Negative 7a squared. And that's the answer to that problem. To point out one quick detail, notice that the way that we write this is in descending order, from the highest exponent to the lowest exponent. All right. A question that some books ask are, what type of polynomial is this? A polynomial is a multiple term expression. This would be a binomial because it's got 2 terms. This term and this term, 2 binomial. All right. If we were asking what this would be qualified as, we would call that a monomial, because monomial means 1 term. Let's look at the next one, which is 3x plus 2y minus 8x minus 7y. All right. Notice that we have a mix of variables, different bases. We have x and we have y. Again, we have x and y. So clearly we're dealing with at least 2 different terms, types of terms. So can we combine the x terms together? And the answer in this case is yes, because they're both x to the unwritten power of 1. So we could do 3x minus 8x, which is going to be negative 5x. And then what about the y terms? Are they alike? Yes, they are alike because they also have an unwritten power of 1. So we can combine 2y minus 7y to get negative 5y. Negative 5y. So the answer to that question is negative 5x minus 5y. And that's pretty much the end of that problem. Again, what kind of polynomial would this be considered? A binomial, because again, there are 2 terms. All right, before we go on to the next problem, I just want to point out another detail about this. Notice that in this problem, there were 2 different variables, but they both all happen to have the same exponent of unwritten 1, okay? But remember, to be alike, they have to have both the same base, or variable, and the same exponent. All right, if we looked at this one, they all had the same base of a, but different exponents, so there were different types of like terms. All right, I'm going to pause this and put a couple more harder problems on the board. Okay, welcome back. I put a few other problems on the board. Notice that I left this up for a second. This was the answer to the last problem we did. And I just wanted to point out one last detail about it, which is, notice how we reported this answer. Okay, the exponents are both 1, so there's not really descending order. However, when we're dealing with the same exponents, we tend to put them in alphabetical order if we're able to. Alright, so I just wanted to point that out. I'll erase that, and let's go to the problem at the top. It's pretty much the same as the others from before. There's just more terms involved. Alright, so we want to look through this and identify the like terms. I'm going to go through this one a little bit faster. Okay, so we have y squared. Are there any other terms with y squared? We could just scan through and we come to this one. So we have this term and this term that are alike, and I'm going to combine them. I'll write the answer to them below. 2y squared minus 12y squared is negative 10y squared. Okay, moving to the next term, we have a y. Scan through, are there any other terms with y? There's this negative 8y. Negative 8y minus 8y is going to be negative 16y. Okay, to the next one, we have 9. That's a constant, there's no variable attached. So any like term will be any other numbers with no variables attached. If we scan through, that would be this 3. So this 9 plus this 3 is 12. Okay? We're pretty much done with that. Let's just quickly look at the form of our answer. Notice it's in descending order. Power of 2, power of 1, and there's no variable here. The constant goes on the end. So that's the answer to that problem. Alright? By the way, these are expressions that we're simplifying by combining like terms. They're not actual equations, so we're not actually solving them for an answer. We'll do that in future videos. Okay, but the next one that we have is, I wanted to make sure that I got a few problems up here with fractions, because I know students have a little more trouble with the fractions and tend to not like the ones with the fractions, so I want to go over these. Alright, you may want to go over some of your fraction basics if you need to. Go over with your tutor or something, but anyway, we'll go over it here. So there's two elements here. There's the whether they're like terms, and then there's also combining the coefficients by fractions. We may or may not, we probably will, have to convert fractions to make the fractions alike if we're able to combine like terms. Let's look at the variables first. Well, we have an x, and we have a term with x here. These two terms are like terms. Just for visual ease, I'm just going to rewrite them, but next to each other for right now. Okay, and then if we look at this term, this is a term with y. This is also a term with y. Again, I'm just going to write these next to each other, and then we'll continue simplifying next step. Okay, so this isn't a step that you have to do, but for beginners, I want to make sure that we can just see the like terms next to each other. And the reason is because once we identify like terms, when we combine them by the coefficient. So we have a coefficient of 1/3 and a coefficient of negative 2/5. Are these, now this is a separate question, are the fractions alike? Remember, you can only add like fractions that have the same denominator. If they're not alike, you need to convert them, okay? In another video, I go over greatest common factor and least common denominator. So you may want to watch those videos to get more insight on converting fractions, specifically for least common denominator. But so you can watch that on your own, but for now, we're going to look at the denominator 3 and the denominator 5. Are they alike? No, they're not alike. How can we make them like fractions? Well, the least common denominator for denominator 3 and 5 is going to be 15. Alright, so that being said, I'm going to multiply the 1/3 by the factor 5 over 5. And I'm going to multiply this fraction, I'm going to squeeze it in here, times 3 over 3. Alright, and I'm going to write what they are below. So remember, multiply across the top, we get 5. Multiply across the bottom, we get 15. And keep the sign, there's no sign, it's positive. and keep the variable x. Same with this. 2 times 3, keep the sign negative, is 6. 5 times 3 is 15. Keep the x. All right? Now they are alike because they have a common denominator. We'll combine them in the next step. But I next want to go to the y terms and these coefficients. Negative 2/3 and 4/7. Okay? Again, fractions. Are the fractions alike in this case? Also, no. All right? And to skip ahead to what the least common denominator would be, in this case it would be 21. How can we make this fraction with a denominator of 21? By multiplying, I'm going to squeeze it in here, the top and bottom by 7. And likewise, how can we convert 4/7 into a common fraction with a denominator of 21? Multiply the top and bottom of this one by 3, and I'll write what they equal below. 2 times 7 is 14. Keep the sign, and it's over 21. Keep the variable y, and then 4 times 3 is 12, and over, again, 21. Keep the variable y. Okay, one thing I just want to point out quickly before we go on is a question sometimes students have. If you look at this and you say to yourself, well, wait a second, 14 over 21, can't I reduce that? It's got a common factor of 7. Well, here's the thing. You can, but if you do, you're just going to go in the reverse direction, and it's going to kind of lead us down a path to nowhere. So yes, this can be reduced, but the point is we needed to convert it so that these are alike. That's why we're not going to convert it. All right? And finally, so let's combine like terms now. We have 5/15 x minus 6/15 x. Okay, we're going to combine by the numerators. 5 minus 6 is going to be negative 1/15 x. And we have, in the y terms, negative 14 over 21y plus 12 over 21y. We're going to combine, again, the numerators. Negative 14 plus 12 is going to be negative 2 over the common denominator 21 with y attached. All right, I'm just going to write the answer up here again so it's in better vision. And that's the end of that problem. Notice that this is a binomial because it's got two terms. They all have the same exponent, so it can't be in descending order, but it is in alphabetical order, x and y. And also, if you're wondering, there's nothing else that we can do to reduce this problem any further. So let me pause this, and I will put up another one. Okay, so I have another problem on the board. This will be our last for this video, and it's a little bit more challenging. Let's look at it and analyze it. There's a few things going on here. First of all, notice that there are two groups. All right, we should always, by order of operations, see if we can simplify in the groups first, and in this case, we can't. They're already simplified. All right, the next thing is there's going to be some distribution involved here. And I go over distribution a little bit more in some other videos, but we're going to do that nevertheless. Also, one last thing I want to say is, notice that there's a negative here, all right? Very important, especially when you're a beginner, is you have to make sure that you keep this negative attached to this 4, especially when you distribute it through to each term, because you want to make sure that you're keeping the negative with the 4 so that the signs of the products are going to be proper and consistent. So let's start on the left, and we're going to look at 2x, and we have to distribute that, multiply it times both terms inside the parentheses. So 2x times x is 2x squared. All right, I'll pause there a second because I want to say, thus far we didn't get into exponents yet, but again, there's another video where I will go over that. 2x times negative 3y is going to be negative 6xy. So we've completed the distribution of this portion. Now we'll go to this portion. Negative 4 times negative 3x squared is going to be positive 12x squared. We have a negative times a negative. And we have negative 4 times negative 2xy, which is going to make positive 8xy. Okay, now we want to analyze it again. Let's pause and analyze it. Now we want to look for like terms. We have x squared and we have x squared. They're alike. And we have xy and xy. These are alike, so I just drew a line together to them to connect them, just to make it obvious. So now we'll just combine. 2x squared plus 12x squared is 14x squared. Negative 6xy plus 8xy is 2xy. Why is it 2xy? Because negative 6 plus 8 makes positive 2. All right, and the xy is the part of the factors of this. They have to have both the same variables. Notice they're the same variables, xy, to the same exponents, unwritten 1. And that's what makes these two terms alike. All right? If we look here, even though you may be tempted because this has an x and this has an x, there's nothing else we can do to reduce or simplify or combine terms here. So this is the answer. And that concludes this video on combining like terms. If you find this video helpful, please give a thumbs up, please share with your friends, and subscribe to the channel. Okay, I'll have other videos. Also check out my other videos on YouTube and Instagram. Thanks for watching, and I'll see you in the next video.